Hey everybody, as you all know, I'm Prateek Choudhary. I'm going to be talking to you about an exciting paradigm that recently the Rails community has started to work towards. Right? It's not fully there, I would say, only a handful of companies are really working on it, but it's ready to use right now. And it's basically a replacement for the kind of modules that need Redis currently, right? Which is the jobs, caching, and the pub sub, which is the action cable, right? And that's what the shift towards the solid stack is. And here's something about me. On social media and everybody else, I'm Prateek-ish. I'm the Associate Director of Engineering at Pattern, and I do quite frequently write about the recent learnings or what's going on in the world of Ruby, Rails, and Postgres specifically. So if you want to be on top of that, and if you like the material, I would encourage you to look at it after the talk sometime. So let's just talk about what a cache really looks like. Yeah. Without the cache, this is what we have all seen at some point, right? You do something, you hit the database, and then you read from it, right? Let's look at it from a cache angle. How does it look like when you have a cache set in place? So that's the ideal scenario now that read becomes a cache miss, because in the ideal scenario, you would have written to the cache, and the next time you try to retrieve it, it would read from the cache. That's a cache hit. That's what we love. That's what we like, the whole point of the cache. If it doesn't find it, maybe because you never really wrote to the cache, or you wrote to the cache at some point, but it's not frequently used, so it's not there anymore. That's a cache miss. Right? All right. This is the data. It's not labeled, but it's basically the cache hit rate of two separate types of caches. One has a cache hit rate of 65%, and then one has a cache hit rate of 85%. Dumb question. Which cache do you think would perform better? The right one? Anybody who wants to say the right one? Okay, so we have consensus that bigger or better cache hit rate is always better. Now, let me just produce you a bit of a case study from Basecamp. So Basecamp stores terabytes of cache, right? But in database, not Redis. Right? Surprising, I know, but it's in database, not Redis. Anybody wants to tell me what would be the exact effect of this? When you do this, what would be the most obvious side effect of doing this kind of a setup? Anybody? I think we have mics flowing over, so. Or if you can just shout out your answer. Anybody wants to take that? If you have, instead of Redis, you have database as your choice of, yeah?
Slow read.
Right? Absolutely. Right? 40% slower. Counterintuitive, I know. But also, you have a better cache size. Why? Because disk is cheap, memory is quite expensive, right? So that's obviously going to happen. This is what they saw as well. With that, that's what you get, right? Second point, cache hits are slower. So individual requests are slower, yes, but the overall application becomes faster at P95 because suddenly instead of 1 week, you're caching 6 months of data because disk is cheap, RAM is expensive, right? That's what we like. We like a good P95. All right. So that challenges the whole performance paradox. We thought Redis would be faster. Again, it would be in most of the cases. In some cases where the application is read heavy, where it can use the cache pretty well, that's when this comes in handy, right? So slower individual operations, but faster overall application, right? And the secret here is the cache hit rate being greater than the cache speed, right? Now let's explore how they're doing it and how they've extracted it for us all to use, which is the topic of my talk, solid stack. Right? So what exactly is the solid stack? And that makes this possible. Now, Rails introduces 3 new components that work together to eliminate Redis. This is what they look like, and this is an exact picture of what they look like. Right? No, okay. Anybody know this reference? Show of hands. Okay, that's from Godzilla, King of the Monsters, but that's okay. You don't need to know it. Now I know, right? I know why why Gautam also said this is a bit controversial, right? Why is this person really on the stage talking bad about Redis and talking about replacing Redis? What's the need when it runs pretty good? I don't have anything like why fix something that's not broken? I know, right? And I know Redis feels the same way towards me right now, speaking on the stage about replacing it, right? Something like this. Now, I'm not going to justify anything here. I still use Redis in most of my production applications. Like, I'll be truthful. But something tells me there's a part of the community that's sitting over here and globally that would benefit from this. Right? Let's look why and why that has potential. Can anybody in this room recognize what this is? Show of hands. Can we get a mic over there or whatever is closer?
It is basically Rails manifesto.
Could you repeat that?
Rails manifesto.
Yeah, it's the Rails doctrine, exactly. Right. Now, something that sticks out from here is convention over configuration, right? And then in 8.1, I think this would work out of the box with minimal configuration. Right? Value integrated systems. The doctrine says we need whatever is needed for the system to work properly and adds value to it should be integrated at whatever abstraction that you can think of, but it needs to be there. Currently, that's not there. That's an external dependency over Redis, right? Progress over stability. This, I mean, it was introduced in 7.x, right? And still not heavily adapted. But this is a start. If you remember the old days, like the asset pipeline was not really there. We had so many iterations of different things. We had Webpacker. We slowly got to where we are right now. This is a start. The more the community adapts to it, the people who benefit from it, we will slowly get there. And that's one of the doctrines that I really like, which is progress over stability. We need to make that progress, and then over time, we'll get stable there. So now let's talk about an analogy. Right? So Redis caching is kind of like a racing bike, right? Incredibly fast. I'm not denying that. It's lightweight, it's efficient. But you can only carry whatever can fit in your backpack. Right? That's the truth. Database caching is kind of like upgrading to a wagon or a truck. You can bring your entire library along with you. It's going to be slower than the bike, but it's going to get you there. And lots of it. Right? Basecamp brought terabytes of it along with them. So by now, let me take a second, and let's hope that there's enough interest to go on without committing Redis blasphemy. And let's talk about Postgres a bit. I know I've been talking about very new things here, but Postgres seems familiar, right? So something that this room is quite familiar with. All right, so here's the comfort zone, right? Something we have already worked on. You already monitor it, you already back it up, right? You already trust it, and then with this way you can cache weeks of data, not hours. Although we can make this setup work with Postgres, it's not fully recommended. Postgres comes with a lot of features that you might not want a cache DB to really give you. So we'll see how SQLite is a more better option out of the box. But since this is familiar, this is sort of the olive branch from my end to make it work with Postgres. And we'll look at how to make it work in prod with some tuning later in the talk. I'm just having some issues today. All right. So with SQLite, as I already told you, right? If you haven't heard Stephen's talk from last year in Rails World, I think I highly recommend it. It's really making all the buzz right now, making it production ready. That's something to consider, of course. Right. All right. These are some of the characteristics of a cache DB. I just told you Postgres by default doesn't really suit well. So what does suit well? Replication, backups, durability. Not really. A cache DB does not need any of this because it's a cache. It's not business data, it's cache. You start off your system without any cache, you will build it. So when you let go of these things, you make your database very, very fast than it already is. And in favor of this argument, we have come a long way from using hard disks to using SSDs to now using NVMe disks that are so much faster than SSDs that the gap has really shortened from using database versus a solution like Redis or Memcached. Even the database, like Postgres and MySQL, would allow you to use RAM, which is called the memory buffer. So really, you're still serving from RAM with a different capacity. All right. Now, here's one last take. I know I've been talking against Redis for a while, but here's the last take in the favor of few of you, who are already considering trying this out. Let's look at some of the shortcomings of the current setup with Redis. It has a hidden cost, right? It has a learning curve. It's expensive. Disk is cheap, as I already told you. And then you can, for example, in a setup like this, if you're already caching 100 MB, you could now be looking at, in the same cost, cache 10 GBs instead. I hope at least just one person here is intrigued enough, because that's really enough for me to go on, because the rest of it is really for you. So now, this is the migration strategy that I'm going to talk about right now. For the practical part, now this isn't really a big bang migration. We're going to really run both systems in parallel. Much like anything bigger that you introduce to a system, you gradually introduce it. Don't really blow things out of the park to reduce the blast radius. Right? Here's the timeline that works in real time. Right? This is the parallel setup. So you start using some of the non-essential jobs, put them on the solid queue paradigm or the solid stack paradigm, and then you go from there. You see, you monitor, and then after a couple of weeks, you start adding more and more things to it, and then at some point when you're stable enough, you do the complete transition. So now this really is a safe setup. It allows you to be safe, be error-proof, and still sort of go about the switch if you do want to. Do it on your existing systems. This is how it looks like. So I'm now only going to talk about the solid queue. There are other two series as well, but then with the shortcoming of this time duration that we have, I'm going to talk about solid queue. Now you install the solid queue, you set it up, you create a base class, and we're going to look at the code shortly. And then you add the adapter accordingly. So this has been added just so that you can do the gradual adoption here. Just one second. This isn't working. Just give me 1 second, sorry. This isn't working.
This is for next one. This is for next one. This is for this.
Okay. All right. So this is the code that I talked about. This is before what you would have essentially, maybe a job that you have written, email job, and it's inheriting from application job. This is the default. If you have at the config level, you have Sidekick, this is going to use Sidekick. What you do instead then is you write a new class, a new base class for solid queue specifically, and then you inherit from application job, right? And then the queue adapter would be set to solid queue. Then instead of inheriting from application job, you would inherit from solid queue job. That would make email job use the solid queue. Yeah? And then let's say there's a very critical job like payment job that would continue to inherit from application job. making it still use Sidekick. Yeah. Okay. Um, but like really, what kind of changes we might need to do if we want to continue to use this? Right? That's the main question that you might have. So let's look at making Postgres work, like for people who are too keen on staying familiar. So here's some of the things that we need to do. A little bit of tuning, not much, that would make it better and act better with the setup that we are going to do. Now, we have already established SSDs are much faster than the spinning disks. Why does Postgres work? Other databases work as well. Postgres specifically works because it has the buffer cache, which keeps the hot data in the RAM. You have control over it. We'll shortly look at it in the tuning slide that we'll have later on. And what we've also described is that network latency and serialization often take longer than the actual cache lookup. And the cache lookup is the part which would be slower in this setup. But then usually it's the other usual suspects that are actually contributing to slow performance. Now, if you are really optimizing from 1 ms to 0.1 ms, this setup is not for you. That would never work. I'm mostly talking about optimizing from 5 seconds to 1 second or below that. The real win is being able to cache 10x more data, leading to dramatic, higher hit rates. But again, as I told you earlier, we need to tune it. Here's some of the optimizations. Like again, I've just shamelessly copied this from the research of Andy Atkinson, but I'll just walk you through it so that you're aware. Right? We need to set unlocked on the solid cache entries table. It's a default table that gets added when you install the solid queue. Now, why is this necessary? Postgres comes with write-ahead logging. That's needed for durability. Do you need that for cache? You don't, right? As we just saw in a characteristic of the DB, cache DB slide. That would make the writes faster, of course. Now, the other one is you make the auto vacuum factors aggressive because you're writing too much data onto a cache DB. You would find dead tuples much faster than a normal setup that's in a relational DB. So by doing this, that's again experimented with. This works much better. Just make sure that the auto vacuum is triggered quite more frequently than before. This one is quite interesting. Random page cost, if you don't know already, is what does the system think is the cost of looking up through a disk. Those values, those defaults in Postgres have been set up looking at hard disks retrievals because it has a spinning disk. It's a physical device, so the boundaries are really certain. In the modern NVMe drives, that's not really the case anymore. So what has seemed to work is setting it to much lower so that the write index is considered, giving it a fair chance to work at scale. The last one is just PG pre-warm. If you're not familiar already, it basically warms the data. So this one would actually take all the data in solid cache entries, make it available for the shared buffer for Postgres. If the size of this table is lesser than your buffer size, all of it is going to be in there. If it's more, then it's going to keep kicking out the data that's least used by the LRU algorithm. All right, now let's talk about monitoring this setup properly. Now this is tuning. You wouldn't know if it's working properly or not until you monitor it, especially in your existing systems. So let's look at that. Usually though, how do we monitor our background jobs? There's a particular UI that's very famous, right? By a particular gem. Anybody wants to just shout that out? Sidekick UI, right? All right. Anybody here who hasn't used it? Probably not. That's my hope. That's not true though. But it's a gem released by Rails. It's called Mission Control Jobs. It does what Sidekick UI does. Sidekick, again, the problem with that, talking in context of this talk, is that it needs Redis to run. Mission Control Jobs has been created keeping in mind the solid stack paradigm, and that would allow a very similar, fairly similar UI that you can keep looking into to monitor your performance of the backend systems, background systems. This is what it looks like. People who are familiar with Sidekick UI would immediately recognize it. It's very similar. The use cases are fairly similar, but again, the backend is entirely driven on the tables that the solid stack creates, right? The problem though, a little bit of problem, to run this, you need an asset pipeline. And I know for sure there would be at least 30% or more here who would be running their Rails app in the API mode. Right? Show of hands if you're running your Rails app in the API mode without the asset pipeline. Wow, that's fairly accurate, right? Around 25 to 30% of you. So this won't work. For this to work, you'll have to, that's wrong. This would work, but for this to work, you'll have to install an asset pipeline. For this to work seamlessly, you can just install PropShaft, which is the new asset pipeline. Some people don't want to do that. If you do not want to do that, here's some, bare necessities. This will tell you the cache hit rate from your, user statistics from the PG stat. Here you can just look at, for the entire setup and call it solid cache entries, what is your current cache hit rate? This is not given by default from the mission control app. This would be something that I feel like is really useful. And this one would sort of give you a list of the queue names that you have, by priority, different priorities, and would really just tell you how many jobs really are pending. So not really full-blown feature like the mission control gem, but at least something that you can get by if you don't really want to install an asset pipeline. Right? This is, again, necessary in any big decision that you take in tech. When you need to roll back everything, something goes wrong, you don't really know what happened. This setup that we have talked about so far that has brought us to where we are right now is fairly simple, right? So this becomes your insurance policy, right? If something goes catastrophically wrong, this is what you can do to roll back. So what this is, I'll just quickly describe it. You're just changing, that's all you're doing. You're just changing the parent of the job. That's a quick code fix. And you can find the currently enqueued jobs that may not be running because of that catastrophic failure. And then you find them out, you push them onto your Sidekick client, and then go about your day. That's a quick incident resolution. Here are some hard-won lessons. If you're using Postgres for this, not really negotiable, that you cannot tune it, you'll have to tune it. You start off with 5% traffic, not really 50%. It's an arbitrary number, but just to say, start small. Right? Then just test, this is summary, so test the rollback procedures before you need them. So again, this is not really full-blown adapted way, so something that you'll have to figure out a bit on your own. So maybe see how your system behaves with the rollback procedures before you go ahead. Cache hit rate, of course, is much greater than cache speed that we have looked at and sort of established throughout this talk. And SQLite works great for the solid stack because it ships. Like if you wanted to make it work for a relational database, you would have to do some tuning to make it work in production properly. But with this one, I think the default config that it ships with today in Rails is really sort of enough for the use case that we have from the solid stack. Right? All right. Any questions that you have?